Alright, today I'm going to do homework number 1, question 4. Going to use some fake numbers. And the first thing we have to realize is that the green car displacement we actually do know in both cases, even though we're only told the red car's displacement. That's because the green car's displacement is just its green car's starting position of x minus the distance the red car went. Why? Well, it's pretty simple to understand, but if the red car moved 1 meter, the green car would have to move, let's say in my case, 200 meters, except that very last meter. So it would go 200 minus 1 meter. If the car moved 50 meters, then the green car would move 200 minus 50 meters. Okay, so we know the displacement of the green car in 2 cases. That's nice. So, good practice when you do physics, just in general. Keep track of everything you know and what you can find, because that's how you're going to solve problems. So we know the red car's speed in 2 different cases, we know the red car's distance in 2 different cases, and we know the green car's distance in 2 different cases. And we know that the red car and the green car move in total time is the same. Why? How do I know they're the same time frame? Well, because they were both moving at the same time. It's just like they cannot be different. It doesn't make any sense for it to be different. It's just like saying, oh, I took 6 seconds to reach you. It doesn't make sense if you waited 5 seconds for me to reach you. The time for me to reach you and you to reach me is the same. If it wasn't, that literally makes no sense. So they have to be the same. It seems obvious, but it's going to be really important later. So, later means now. Distance equals speed times time, or distance divided by speed equals time. These are equivalent. This is important. Why is this important? Because we know the distance of the red car. We know the speed of the red car, which means we can find the time of the red car. If we can find the time of the red car, we know the time of the green car. And that would be helpful. So we can find time for both scenarios. For the red car, which would be both cars. So just because I want to, I'm going to change the red car's kilometers per hour into meters per second. It is not necessary. I just like working in meters per second because I just think it's better. So I'll change kilometers an hour to meters per second. The general rule of thumb for this is just divide by 3.6, but here's the long way. So I turn 25 kilometers per hour into meters per second, and since I know 50 kilometers per hour is just 2 times 25 kilometers per hour, I just took the answer from here and times by 2, because I know that's fine. So now that we know the speed of the red car, how far it goes, and now we need to figure out the time. The time is pretty easy to figure out. You can find it just using the fact that distance divided by speed is time. And we know the distance and we know the speed in both cases. So I'm just going to find time. So let's see. Oh, I found time here. So in the first case, the car is going 50 meters. And at this speed, just gives me this time and then a different speed, different distance, different amount of time. Wonderful. So now we got 2 different times, and for both of these cases, this also applies to the green car. So a key realization to note is that to find 2 variables, which is the acceleration of the green car and the acceleration and the velocity of the green car, which you both want to know, we need to use 2 different equations. And we actually do have 2 different equations. Think about it. What do we know about the green car? We know the distance it went, and we know the time for both cases, for 2 different cases. So we can make 2 equations. So what equation uses distance and time and contains acceleration and speed? It's a distance formula again. It's not very surprising. Most of the tough questions in kinematics use this equation because it's the only difficult one, at least in my opinion. So let's put everything we know about the green car into this formula. We know when the green car moves 150 meters, or 200 minus the red car's distance. This is how much it moves, its displacement, so this is always positive. You could put a negative sign if you wanted to, that's perfectly fine. I just put the negative sign at the end after I do all my work, but probably putting the negative here would be smarter, doesn't matter. And then we plug in all the values, 1/2 a t squared, we know what t is in both cases, and we know what time is, we also know what distance is in both cases. So obviously you probably realize that velocity and acceleration are equal in both cases because it's the same car. But we want to figure out what velocity and acceleration actually is. So this is just a system of equations. A lot of you don't need to watch this video anymore, you can stop here. But let's say you don't know how to solve this. So first I'm going to get rid of this times squared. So I just squared times in both cases. And I'm left with this equation. So to simply clean it up, I just multiplied the coefficients together. This square should be gone. And then boom, I have this. And now I'm going to find, let's see which one I want to find first. I guess I'll find acceleration first because that's what the question asks. So if we made both of the velocity values equal, then we could just simply subtract the equations together and find acceleration. By values, I mean coefficients, because we know the velocity of the green car is the same in both cases. And we know the acceleration is 2. So if the coefficient in front of the velocity is the same, these two would be the same. So how can we make it the same? I decided to make the bottom equal to the top. If you look this up, they'll probably tell you to cross multiply. That works as well, just as long as you get the velocities to be equal to each other in both equations. So I multiplied the bottom equation by 7.2 divided by 6.12. I didn't do 7.2 divided 6.12 and like write it down and then multiply by that because I want to keep every single decimal. So just type it in like this because decimals absolutely matter. Try not to round. This note is for people that are confused. Most likely it's not you. Alright, so after doing that multiplication, this is the top equation. Now this is the new bottom equation after I did the multiplying. So we notice these velocities are equal. I can cancel them out. Wonderful. So I subtract the top equation and the bottom equation. Get left with this many meters. I just dropped the units. I didn't care. Equals this much acceleration. And then I divide both sides by the coefficient for an acceleration and get the new acceleration. So we know the car is going to the left, so this acceleration is to the left. Also, this acceleration is in meters per second squared because we changed to meters per second. Strangely enough, they don't ask you to turn it back into kilometers per hour, so we can just stop there. Finding speed, pretty trivial. You just plug in acceleration to literally any of these two equations. Doesn't matter which one. I decided to put it into the top one. So then plug in the acceleration I found. And then boom. We can find velocity very easily. Just simple math. Remember the velocity is negative as well because it's going to the left. And then turn this into kilometers per hour because I think they ask it for in kilometers per hour. So don't forget that step. If you do, that kind of sucks. If they don't ask in kilometers per hour, don't. Just make sure your units are right. That's about it.